So we have is a term. T1 is 4. So to me that means the point 1, 4. T2 is 7. So what point do you think that is? The point 2, 7. T3 equals 10. That's the point. 3, 10. And finally the last one's the point 4, 13. So I go down here and I label this axis and I go, okay, so here's what we're going to do with you. We're going to call the y-axis value and we're going to call the x-axis term number. So we call you value and we call you term number, okay? Now, if you make it too narrow like this, 1, 2, 3, 4, it looks not good. So if you have enough space, what I would generally do is I would generally space it out as far as you can. So I'll use 3 blocks for 1, 3 blocks for 2, 3 blocks for 3, 3 blocks for 4. See the way it spaces it out nicely? And then I have to go as high as 13, don't I? Now how many blocks do I have here? 2, 4, 6, 8, 10. They didn't quite give me enough for 13, did they? So I'm going to have to go up in 2s, haven't I? So that'll be 2, 4, 6, 8, 10, 12, 14, 16. Everybody see that? And then I'm going to draw the numbers together. So the first one's 1, 4, isn't it? And then we have 2, 7. Where'd 7 be? Yeah. 3 and 10. Okay. Finally followed by 4 and 13. 4 and 13 be in between 12 and 14. And you'll see that this is a straight line, which means it's a linear sequence because it keeps going up by 3 every time. Okay, you draw to number 4 now, okay? So here's question 4. And it says that she's saving according to week numbers. So I think she's saving at €10 a week, isn't she? And we've got to do is we got to represent this on a graph. Okay. So you do the same thing you did last time. I can go 1, 2, 3. Nope, can't do that. So every block's worth a tenner. Is that okay? 10. I sort of do it like this. I sort of don't draw in every number. Just keeps it a bit neater, doesn't it? Well, see the way if I start throwing in the 40 and the 20, it starts to look a bit congested. Would you agree with that? So you can sort of space it out a little bit. Then I have to go all the way up to 5. So I'm going to make every 2 blocks worth 1. And I've made one mistake here. I haven't labeled anything. So I need to call this week number. You know this from science, don't you? Yeah. Week number and amount saved. In euro, yeah. Okay. First one's 110. Next one is 220, 330, 440, and 550. And you have yourself a nice line there. Clear now. Okay, question 1. Is the graph linear? Yes, because it's a straight line. Or the other thing is you can say is the amount goes up the same amount each time. Goes up a tenner each time. Use the pattern to show the amount you will have saved at the end of the 12th week. Well, if 5 gives you 50 and 4 gives you 40, I think 12 will give you 120. Oh, find the equation of the line you have drawn. That's an interesting one. So we've done coordinate geometry, have we yet? I don't think we have, actually. We haven't. Okay. So what we're going to teach you now is we're going to use y equals mx plus c. We'll have to reevaluate the way we do this in future. Okay, and I'll show you what this means now, okay? The c value is where your line would hit the axis. Where would my line hit the axis, do you think? Would you all agree it's 0? Okay. The m value is the amount you go up each time. So how much do you go up each time? So it's actually the equation y equals 10x. We won't be able to ask you that in the summer test because we haven't covered coordinate geometry yet. Is that right? If that comes up again, we'll do it. Now, use the equation to find out what Cara would have saved at the end of the 20th week. Well, the x-axis is the number of weeks. Would you agree with that? So all you have to do is replace the x value with 20 because x equals 20 represents 20 weeks. You already know how to do it, don't you? You just multiply your answer by 10 because you save a tenner every week, don't you? So the answer would be 200. So we have a number of edges, don't we? 1, 2, 3, 4, 5, 6. Then we have 7, 8, 9, 10, and 11. I think it's gone up by 5 each time, isn't it? So what would the next one be? Would everybody be happy with 26? Why is it linear? Going up 5 every. This isn't even a graph question. And then it wants me to find an expression for the Tn. Does anybody remember how to do Tn for a linear? What's the jump? So what do I write down? 5, 5n. And then you compare 5 to the first one. 5 compared to 6, bigger or smaller? How much do I have to add to it to make it into the 6? So the answer is actually 5n plus 1. Is that okay? And there's another way of doing that. It's called the Tn formula. If some of you end up using this. The A value is the first value in your sequence, which is 6. The D value is how much it's jumping up by each time. 5. And then you multiply 5 by 5m minus 1. What you get? 5m minus 5. And what's 6 take away 5? So you end up with 5m plus 1. Two ways of doing the same question. We're going to have to draw a graph for this, okay? So off you go. All the way up to 4, I believe. So it's going to be do it like this. 1, 2, 3, 4. Okay, I have to do the equation of the line again. That's not going to be fun. Actually, it's grand. We already have that form. And then we have to go as high as 21, don't we? So 4, 8, 12, 16, 20. I'd advise you to do that. Go up in twos. So each block's worth 2. Okay. So what do we get? 1, 6, is it? Yeah. Next one. 2 and 11. Halfway between 10 and 12. Yeah. Next one after that. 3. 3, 16. Yeah. 4, 21. Okay. And you have yourself a line. Yeah. Now, here's the deal with this, okay? So, do you know that formula we got earlier? What was the formula we got earlier? But remember the one we did in the last question. See the 5m plus 1? Ever see the 5m plus 1? I think we already have this then, don't we? 5m plus 1. It has a slope of 5. And it would hit the axis, huh? Let's see where it hit the axis if we were to draw it. It actually hit the axis, huh? 1. So we actually already have it using the formula we did earlier. So we can actually use 5m plus 1 is perfect. It's the same thing as mx plus c. The slope is 5 and the intercept is 1. So that's okay. Slope means how much it goes up by each time. It goes up 5 edges for every new hexagon. Yes.
How is it 1? Like 5 and like after you said plus 1.
Did we not work that out here? Using part 3.
Okay, it's the same.
Yeah. Okay. And if you drew the slope further down, which I also showed earlier, if you drew that slope further down, it hits at 1. That point would be 1. You don't have to draw it any further, by the way. That's the correct way of drawing it, is what we have there. Okay? The slope is 5. What does the slope mean in the context? 5 new edges every time a hexagon is added. See the way there's context to it? What I'll do is, first of all, why is this one a quadratic pattern? What's the reason we all want to use? First difference is not the same, but the second difference is the same. Second difference is constant. We did that before we left, didn't we? Okay. What's the second difference between the terms? What is the second difference? 2. I get what you're thinking. See, all of these are first differences. And all the ones in the green box are all the second differences. I get you were doing it made sense. So, would you all agree with 2? Now, it's your job to draw this. So, T1 is 4, so what do you think that means? T1 is just below the 5 mark, agreed? How do I know these is going up in 5s? Every 2 is worth 10, yeah. And then T2 is worth 7. So sorry I had to guess it. Sort of just under halfway between 5 and 10. Now you guys gotta draw the rest of them now. T3 is 12. Sort of here. Okay. T4 is 19. So just below the 20 mark. And T5 is 28, just below the 30. So as everybody knows, it's a bit of a curve rather than a straight line. So the shape of a graph is a curve because it's a quadratic.